Hello everyone. So today we are going to graph some exponential function equation. So here we have the equation y is equal to 2 to the power of x plus 3 minus 2. But before we go that, we will try to review first what we have learned from my last video, where we have the equation y is equivalent to a to the power of x minus c plus k. And here we have this new one, this plus and minus. So as you can see here, if we are talking about the k, so k represents the vertical shifting, so it goes up and down. So it's a vertical shifting. If it's positive, then the graph goes up. If it's negative, then the graph goes down. While the value for your c, if c is positive, then we are going to have going to the right, and if the value of c is negative, then it's going to the left. So how do we get the value of c? So we say x minus c is equal to 0, then x would become c. So that is how to find the value of c. And regarding with this plus and minus here, for example, we have a y equals plus positive a to the power of x. So this one will tells you that our graph will actually goes up. And if we are going to have y is equivalent to negative a to the power of x, then the graph actually goes down. So these are the most important thing that we are going to use in graphing our exponential equation. So first, with our equation, we need to locate what is our a, what is our c, and what is our k. So here, first we need to locate our k. So what is the value of our k in this graph? So we know that the value of k is equal to negative 2. So since k is equivalent to negative 2, this negative 2 represents also as our asymptote. So in our graph, we can locate this negative 2 if this is negative 1, negative 2. So probably this would be our asymptote here. And next, we are going to locate our c. So what is the c in the graph? So first, we need to equate this equation to find the value of c. So x plus 3 is equal to 0. Therefore, x is equivalent to negative 3. Therefore, c is equivalent to negative 3. So where is negative 3 in the graph? So we say x equals negative 3. We have negative 1, negative 2, negative 3. So we are just going to make an imaginary line here. So as we know that our new point of origin would be here. So from our original point of origin, then we have our new point of origin. And next that we need to look at is our a. What is the value of our a? Is equal to 2. So since a is equal to 2, then therefore we will just have to graph the equation y equals 2 to the power of x. But we need to use this one from our new point of origin. Now, since the value here is positive, so we are going to use this. Therefore, we are expecting that the graph will go up. And at the same time, we are expecting that we are going to have an exponential growth since our a is greater than 1. So we can make a table. So this would be our x, this would become our y. Then maybe we can start from negative 2. Negative 2, negative 1, 0, 1, and 2. So if we say x is equivalent to 2 to the is negative 2, so we say 2 to the power of negative 2, then that's going to be 2 to the power of negative 2, and that's going to be 1/4. X, so we have x equals negative 1, so 2 to the power of negative 1, that will give us 1/2. 2 to the power of 0, we can have 1. 2 to the power of 1, we can have 2. And then 2 to the power of 2, we can have 4. So where are we going to graph this? So instead of graphing this from this point, we are going to start from our new point of origin. So if we say, so this one now would become our new -1, this would become our new -2, this would become our new +1, this would become our new +2. So probably I'm going to start with a 0. So 0, we can have 1, so that is going to be here. If we say from here, we can have 1 to the right, which is +1. So what's the value of 1? We have 2, so we say 1, 2. And if we have 2, if x equals to 2 from our new point of origin, so 1, 2, then we have 4, so we say 1, 2, 3, 4. If we have -1, we are going to have 1/2, so from here we can have 1/2, and then here we have 1/4. So our graph, so we can connect now our dots. So connecting our dots, then our exponential graph will looks like this. Okay. So next we are going to identify our domain. So how do we identify our domain? So the domain of our function, as you can see here, that the domain is the x value of the function. So as you can see here that in terms of the domain, this graph will go to the left in infinity, and this one will also go to the right with the infinity. So we can say actually that our domain of the function, we will have all x, or we can write -infinity to +infinity. Now, how about for the range of the function? How can you find the range of the function? So to find the range of a function, all we need to do is look at the y value. So if you're going to look at the y values of this graph, it looks like that our value of our y is from -2 going up. Since it does not touch -2 because of this asymptote, then we can say that we can have an open graph here, and then it's going up to infinity. So here we can say that our range of the function would become from -2 open parenthesis going to infinity positive, or we can just say y is greater than -2. So this is our graph. So let's go to the next example. So for our next example, we will have y is equal to 3 to the power of -x plus 2. Oh, we have a new thing here. So if ever we are going to have a negative to the value of x, or we have a negative exponent connecting to x, we will make this one into positive. So how we can write the one into positive? So we can rewrite the one by saying y is equivalent to 3 to the power of -1 raised to the power of x plus 2, and then we say y is equivalent to 1/3 because of this -1 raised to the power of x plus 2. So since we have now a positive, so we can now identify which is our c, which is our k, and which is our a. So first, identifying our k. What is our k in the graph? So we say we have +2. So we know actually that our graph goes up by 2 points. So at the same time, this is our asymptote. So I'm just going to make an imaginary line here. So this would become y is equivalent to 2. Next, locating our c. So c in the graph. So first, we need to equate this one into 0. So if we say x equivalent to 0, then therefore c is also 0. So since c is 0, then therefore we can say that we are just going to use this new point of origin here. So in this particular graph, there is no going left or going right, but we have only going up by 2 points. And next, we are going to use our a. So we have a is equivalent to 1/3. So since we know that a is 1/3, and this is an example of an exponential decay, so we're expecting a graph that probably looks like that because of the nature of our a, which is between 0 and 1. So now it's time to graph. So we are going to graph only the equation y is equivalent to 1/3 to the power of x, and we can use our table. So here we are going to have x, we are going to have y. Maybe I will just start from -1. -1, we have 0, 1, and 2. So if we say 1/3 to the power of -1, what would be that value? So 1/3 to the power of -1, so we have 1/3 to the power of -1, so that's going to be 3. So this is 3. So if this is 0, this could be 1. If this would become 1, this is 1/3. And then if we have x to the power of 2, then we have 1/9. So where are we going to graph this one? We are going to graph this to our new point of origin, not from the original, but from the new one. So we will start from 0. So remember last time that our intercept is always above the new from the point of origin, okay? So if we say 0, then we are going to have 1, not from the new one, not from the old one, sorry, instead, but use the new one, okay? So we have, so I'll just put a number here so that it goes 1, 2, 3, 4. Here we have 1, 2, 3, 4, 5, -1, -2, -3, -4, okay. So let's graph. So if we say 0, we can have 1. So 1 from the original, from the new point of origin, 2. So next is we have 1. So 1 represents 1/3. So just imagine point 1/3 from here. It looks like that. If we have 2, then we have 1/9. If we have -1, we are going to have 3. So we say 1, 2, and 3. So if we are going to graph this, then the graph will looks like this. Yeah. So that's how our graph looks like. So let's talk about our domain. What can you notice about the domain of the function? So the domain of the function, we can still say it's going to be all x because it goes left to right, positive infinity to negative infinity. How about the range of our function? So the range of our function, what you have noticed, we just started from -2. So the range is always greater than or less than your k. It depends on the value here. So as you can see, whatever your k is, so you can just say y is greater than your k. Since our k is 2, then we have 2. Or you say open to going to positive infinity. It depends how you write your range. Okay, so let's go to our last example. So in our last example here, we have a new sign, as you can see here. So what have you noticed with that sign? So that sign identifies that our graph is actually going down, okay? So it goes down because of the negative here. So instead of 1 point going up, we have 1 point going down to our intercept. So let's try to identify, let's say first our x. So x is positive, so no worries. We don't need to fix this value of our a. So if this is negative, then we need to fix. Since it's positive, we don't need to fix this. So locating our k. So k, what's the value of our k? We have 3. So I'll just look at 3. So we say 1, 2, 3. So we will make our imaginary line, okay? And then we say this value, finding for c. So we say x plus 1 is equal to 0. Therefore, x would become -1. Therefore, c is equivalent to -1. Where is -1? In this part here. So let's just make an imaginary line. So this now would become our new point of origin. And then I'm just going to graph this value here. So we say y is equivalent to -4 to the power of x. So negative 4 to the power of x, let's make our table since the value is very big. So probably I'll just use from negative 1, 0, and 1. You can extend more, but since the value is very big, it's going to be, if we say 2, so 4 to the power of 2 is 16, and then my graph is not enough, then I'll just use 3 points from this. So it's very important that when graphing, you need to locate at least 3, 4, or 5 points so that you can have a smooth graph, okay? So if we say negative 1, so what would become the value if we say negative 1? So negative 4 to the power of negative 1, so this would become negative 1/4. So we say this is negative 1/4. Here 4 to the power of 0 is 1, so this would become negative 1, and then here we have negative 4. So let's try to graph. Remember that you need to use this one to our new point of origin and not from here, okay? Because we have already made our transformation. So we have negative 1, so from the new point of origin, negative 1 is here, so we say negative 1/4. So from here, just make a negative 1/4 over there. And then we say negative 1. So from 0, negative 1 is actually the negative value to here. So negative 1 would become here because it's 1 point going down from our new point of origin. And then if we say 1, which is this value from the new point of origin, so we say 1, so we need to count negative 4. So we say 1, 2, 3, 4. So this is our 3 points in the graph. So if we graph this one, our graph looks like that. Yeah. So that is how our graph looks like. So locating our domain. So this is the domain of our function. So the domain of our function, so we can just say all x, or from positive to negative infinity, and then the range of our function is going to be, as you can see, because of this negative, it means to say we are going to have less than and not greater than because of that negative value here. So we say y is less than the value of our k, which is 3. Okay, so thank you so much for watching. I hope you understand the lesson and see you on my next video.